everything in the real plane is in here. If you look in the cockpit, all the controls, everything is in there. It took the man 9 years to build these
Yeah,
three.
was this the Korean guy?
God,
Yes,
Yeah.
young Park.
Yeah.
look
yeah,
at the
yeah,
He
detail.
started off with, he's a dentist, dental tools and a roll of sheet aluminum. And later got our tools and all, but see, this is what he did at, after work.
Yeah.
And somebody asked me, how could you do that for 9 years? And I said, if you had a wife like mine, you'd be in the garage for 9, maybe take 10. This fellow, see these? Okay, built all these engines, and those aren't kids electric trains, those are steam powered. And he was a chemist.
Yeah.
And see on top of these wooden, those are made out of matchsticks without heads, and that fellow was an aeronautical engineer, and all his work is always covered up. Couldn't see this, so as a hobbyist, he bought these matchsticks, like this thing where you could see what it is. Stamped rivets, those are actual, each one is a rivet, and the projectiles, the bullets are actually 3-piece.
Yeah.
Hi, folks.
See,
They drill a hole through the hair. Took them 10 weeks.
The steam engine basically converts linear motion,
they're using air, probably,
Yeah.
air right
vertical or
now. But still,
horizontal, and into circular motion. So you boil all the bearings and injections. I know because I did it. If you had machines, like the place I worked at, it was an old building on North Island, New Zealand. The closest, it's too heavy to put on a wagon. Now the way that it works, when I bring the flywheel back, the piston will draw back, it'll draw some flame in, it's an alcohol flame. Then that valve you see rubbing or going back and forth, that'll close off the cylinder. The flame in the cylinder will burn up the oxygen. That'll create a vacuum, that'll draw the piston back again, and then the flywheel will carry it through to the next cycle. So we'll see if we get this running.
Oh, that's so cool.
That's your throttle, where you place the flame.
Is that right?
They run quite fast, but they have very little torque. So, this is a little marine engine, so you don't see a radiator, because these were used commonly in radio-controlled boats. So that'd be your coolant, your water coolant source. Let's see if we get this right. It's a little 4-cylinder, straight 4-cylinder. It's a genuine running little engine. Now this one's kind of neat. This was built in a high school in Canada in 1930. The story goes there were 22 boys in the class. They had to do all the detailed drawings on all the parts. They had to make wooden patterns for all the castings. They're all sand castings. They did the castings. They did all the machine work, put them together, and 22 of them went home with an engine. Now this is what's called a hit and miss engine, and you'll recognize it when it's running. It doesn't fire on every rotation, but what happens, and there's no throttle, so what we have is a centrifugal governor, and the governor has 2 weights. You see those little weights? As it gets up to a certain RPM, the weights will sling out from centrifugal force. They push a rod into the little gearbox here, lifts the exhaust valve, and that's what determines how fast it's going to go. see those weights going in and out. That's a common type of a governor you'll see on a lot of steam engines. If I put a load on it, it'll smooth it out. Because now it's working under it. Now the governor is never getting to its maximum RPM. This type of an engine was very commonly used on water pumps, washing machines, anything on a farm. It's, you know, before electricity was put through the whole, installed through the whole country, you had to have an engine to run everything. Actually, Maytag produced washing machines with this type of a motor and had a pedal start on it. So on wash day, the lady in the house had to take a basket of clothes or soap and a can of gasoline to do the laundry. It was built in the late 40s by a gentleman from the Los Angeles area who was a landscape architect, and took him 7 years to put together. The components, the drive components on this end are out of a slot machine, and the drive components up on this end, seen from this side, is from a Norden bomb sight. Now, a Norden bomb sight had a lot of mechanism in it. We have one on display. It's on the other side of that wall, on the outside, and you can look at that. They were used in the Second World War for accuracy in bombing. It was a big step in the accuracy of the bombers. Actually, the bombardier sighted the Norden bomb sight, and the pilot turned the control of the engine of the plane over to him, and it would actually fly the plane over the target, release the bombs, and he'd turn it off and he'd turn the control back over to the pilot. So what we're building right now here in the shop is a 5-cylinder radial aircraft engine. I'll show you some of the parts of a Kinner 5-cylinder radial. The full-size engine actually produces about 100 horsepower. I found a website, you put different data in, piston diameter. This is a piston. I don't have the pin all the way in so it doesn't move too freely. Connecting rod. But you put the piston diameter in, the stroke, number of cylinders, it tells me we'll get about 12 horsepower out of it. It's about a 100 cc. These are the cylinders. These are cast iron. This is part of the connecting rod assembly. Now when I made the small connecting rod, this is called the master rod, and these are the slave rods. So when I made them, I actually made them as square because it was easier to hang on to them and machine them and everything. Then I made a little fixture that goes in the lathe that holds them, and then I have a center back here. So that's how I was able to generate the round on them. These are made out of stainless steel.
He was a master machinist, right? Grandpa?
Known as 17-4 P8.
Your dad?
Need to leave.
I told you about a positive displacement oil pump.
Yeah.
That's the oil pump. The two gears are what give you the pressure. The oil comes in here, it's picked up by the gap between the teeth. It can't go back that way because of the mesh of the teeth. So it'll go out a hole back here, which will feed into the back of the connecting rod mechanism. Timing. And what I did here, I used a drop indicator to find out where top dead center was on each individual cylinder. And then I marked the gears, and then we'll go back and grind the cams back to that mark on the gear. And this is how the engine actually operates around like that. Let's see.
That is gorgeous.
It's a radial engine. Now there is a rotary engine too. We have one out there. In a rotary engine, which they don't even use anymore, the whole engine rotates. So you can imagine the inertia you have with an engine that weighs maybe 300 pounds rotating. There's one on the very first display case on the far end. They were used on the Sopwith Camel in the First World War, a rotary engine. And what's interesting about them, they didn't have a throttle. They were set up to run at a certain RPM, but they had a kill switch on the stick to kill the magneto. all we need is airflow to cool the engine. We're not gonna fly it.
Well, that would really pull though. But a lot of, that would really pull, that propeller will really pull.
Oh, yeah. And here's a little something. The numbers on the prop, the first number tells you the length of the prop. The second number tells you how much it progresses through the air in each revolution. So this prop is 6 foot 10 inch. So it's each rotation is 6 foot 10 inch through the air. Radial engine, you always see them cranking the blades through a couple of times. Because if you can't pull that blade through, that means you have oil in the cylinders. So you have to take the spark plugs out of the bottom 2 cylinders and drain the oil out. Because if you try to start it with the oil in there, you'll bend everything. I mean, you'll bend the crankshaft and connecting rods and everything. So yeah, give us about another year and we should have it running.
So-and-so avenue at this venue.